In this video, I am going to discuss the diode resistance, that is the PN junction diode resistance. Already we have discussed the PN junction diode construction and the current equation of the PN junction diode and operation of the PN junction diode, that is a forward bias and reverse bias also. So now here I am going to discuss diode resistance, what is diode resistance and how many types of resistance and what is the importance of each resistance. See, resistance is a property of an element which opposes the flow of current. So resistance is the property of an element which opposes the flow of current. If the diode opposes the flow of current, then it is called a resistance. Just now we have discussed diode operation in forward bias and reverse bias. In forward bias, the PN junction opposes the flow of majority carriers, and similarly in reverse bias, the PN junction opposes the flow of majority carriers. So finally the PN junction opposes the flow of majority carriers, so we can write the PN junction acts as a resistance. So the resistance offered by the PN junction diode is called diode resistance. Now I am drawing the PN junction diode construction part. Let us assume it is a one PN junction diode which consists of the depletion layer. The layer is defined exactly at middle of the PN junction like this, right? So this layer consists of immobile ions, so just I am drawing like this dotted lines, and finally this junction, whatever the PN junction, opposes the flow of majority carriers. This side I am assuming p-type semiconductor, this is n-type semiconductor, and this terminal is an anode and this terminal is a cathode. So without any external biasing, this junction does not allow the carriers flow, so it is acts as a resistance. So that junction offers a resistance is called PN junction. It acts like this. Okay, there is not an internal symbol, but it acts as a one resistor only. This resistance is also called as distribution resistance because it is physically not connected. The device offers that flow of charge, opposes the flow of charge carriers property. That's why we can write it is acts as a resistance only. So this type of resistance are also called as distributed resistances. This PN junction can be operates in two regions. One is a forward bias and another is a reverse bias region. So in forward bias state, it acts as an on switch after cut-in voltage only. So up to cut-in voltage, this junction does not allow the current. So we can write in forward bias also this diode offers the resistance. So those resistance are generally two types. One type of resistance is a static resistance. Type of resistance is a dynamic resistance. Generally we have to take these two resistances in forward bias only. Because in reverse bias, just like the PN junction diode acts as a open circuit, it offers very high resistance. But in forward bias, up to particular voltage, this junction does not allow the current. After that voltage, this junction allows the current. So in forward bias cases, the resistance will changes here. That's why here we have to discuss two types of resistances. One type of resistance is a static resistance. Static resistance is also called as DC resistance because the resistance offered by the PN junction diode whenever it excited by the DC supply. Here I wrote one simple point. The resistance offered by the diode for the DC signals. If the PN junction diode is operated by the DC supplies, that is in forward bias, then the junction offers a resistance up to particular voltage levels with respect to the voltage levels. So that resistance is called a static resistance, and this resistance consists of fixed value, stationary value. That's why the name is here static resistance. And the simple equation of this resistance is R is equal to V by I, voltage by current. The voltage applied to the diode and current through the diode. The ratio of these two explains the static resistance. Now coming to the dynamic resistance. Dynamic resistance is also called as AC resistance. Now the definition explains simple statement, the resistance offered by the diode for the AC signals. If the diode is excited by the AC signal, then the diode offers a resistance. That resistance is called dynamic resistance. In this case, the resistance of the diode is not constant and not fixed. It changes with respect to the applied AC signal. AC signal is nothing but it's a variable voltage, variable current. If the voltage is changes with respect to the time, then the diode resistance also changes. That's why the name of the resistance is here dynamic resistance. And this resistance is due to the AC signals. So another name of this one is a AC resistance. So now I'm denoting this AC resistance by the small RA, R. So I'm writing RAC. Then we can write here change in voltage by change in current, dV by di. So finally we want this equation now dV by di. And already we know that I is a diode current, that diode current is equal to I naught into e to the power of V by eta Vt minus 1. This is standard diode current equation. Now from this we want here dV by di. That's why here I want to differentiate this current equation with respect to the voltage. Then becomes a di by dV. Differentiate the above equation, current equation with respect to the voltage. So I naught is a reverse saturation current that is independent of the voltage. So we can take that I naught as a constant. So differentiation of the constant is 0. So that part I am not writing now. And the remaining part I naught into e to the power of V by eta Vt is there. So I naught write as this. And differentiation of e power x, e power ax is a into e power ax. So from that I am writing now here a is a V by eta Vt into e to the power of V by eta Vt. Minus I naught is there, so differentiation of I naught should be 0, so that is not required. Now the final equation becomes here I naught into V by eta Vt into e power V by eta Vt. So I naught into e power V by eta Vt is approximately equal to the diode current. So that's why I am writing now this complete equation is with respect to the voltage, this becomes 1 now. So 1 by eta Vt into diode current I. Now from this equation directly I want to write the dynamic resistance dV by di. dV by di becomes now eta Vt by I. This is the standard equation of the dynamic resistance, RAC. So if the diode current is increases, the dynamic resistance is decreases. So dynamic resistance is always inversely proportional to the forward current or current to the PN junction diode. So these two equations are important. Here I have explained a static resistance R is equal to V by I, and similarly dynamic resistance eta Vt by I. Dynamic resistance depends on the temperature also, because Vt is a volt equivalent temperature. This Vt is equal to, we can write here T by 11,600. So this voltage value, this Vt value changes with respect to the time. So here I have explained the diode resistance and types of diode resistances.